equals 3, x equals less than or equal to 3, and x is less than 3. So I'll give you a second to see if you can figure that out. First off, what kind of line would this be? They're all straight, so give me a direction. Yes, they would be all vertical lines at 3. So say we have 1, 2, 3. Oh, I just need to. How would you graph x equals 3? Yeah, a straight line. Everybody knows that since grade 9, I think. Yes? Okay. How would you graph x is less than or equal to 3? How would that change? Okay, let's look ahead. How would it change if it was x is less than 3? Now, I know in grade 9 you did number lines with inequalities, and so if we think about that for a second, if we were just to do a number line, how would you graph x is less than 3 there? A circle not filled in and going to the left. So if this is a linear inequality, this would mean that you would actually have a point there, which means it's a point through the whole x is 3 no matter what the y is. But then it's everything less to that, so we can't actually put an arrow here, but what it means is it includes this whole region here, so we actually shade everything to the left. And then what's the difference between B and C is we have 1, 2, 3, and because it doesn't include 3, normally on a number line we'd have a circle open. How do we indicate that? This silly little line, that's right. It looks like an asymptote, but it really isn't. It's basically everything up to that, but it can't include 3. Oh, funny looking line. Anyway, so that would be the difference between those. So the circle included is the line is included at 3. The circle not filled in means we have to indicate that with a dashed line. Okay, so those are easy when we can relate it to a number line and we know which way is going left or right or less and great. But when we actually have a line that's got a little bit of slope to it, we don't know where necessarily that it's greater than or less than. Actually, it's not too bad when it's written in slope-intercept form because we need to know that the y's are always greater than the function. When it's written like this, it's a little bit harder to see. Okay, so here's your process of how you need to do this. The first thing you have to do is graph the line using any method of choice. So in grade 10, you learned how to do this. Well, grade 9, you learned how to graph a line by using a table of values. In grade 10, you learned the slope-intercept method of graphing, and then there was another method, the intercept method, where you find the x-intercept and the y-intercept, and you just put the 2 points and then cross, made a line as well. Okay, so that's any method of your choice. So a less than or greater than means the solution doesn't include the line, so it's a dashed line. This is where you should have a ruler here. A dashed line. My S doesn't look that great. It's a dashed line. And a less than or equal to or a greater than or equal to means it's a solid line. Solid line because the line is part of the solution. After you're done drawing the line, you need to choose a test point to see if that region where the test point is true or false. If it's true, you're supposed to shade where that is. I highly recommend using 2 test points because you could do it wrong on the one and you get a false positive or whatever. So if you do 2, then you know for sure you're right. So of course then after you figure out where it's true, that's where you're going to shade. Okay, so how do I graph y is greater than or equal to x minus 2? Well, first off I have a y-axis and an x-axis, yes? And what's the method of choice for this one? Slope-intercept form. So you put a point on. -2, and it has a slope of 1, so I'm going up 1 over 1. Does everybody see how I'm getting that line? I see a lot of blank faces here. Do I do a solid line or a dashed line? Solid. Why is it solid? Because it's got that equal sign. Yes? So I'm going to take my ruler and I'm going to make that line go through there. I'll even make it blue to match. Okay? Now, because the line goes on forever, I need to have arrows or you'll lose a half mark. Now we have to figure out, are we going to shade on the left or the right? So I always test the point 0, 0 because that's probably the easiest thing to sub in, because when you have zeros, they just wipe away. But you cannot use a test point that's on the line. It has to be either on one side or the other. So does everybody see my test point of 0, 0? Yes? So I'm going to sub in 0 in for my x and this 0 in for my y. Does everybody see what I'm doing? And I'm going to see if the inequality is true. If it's true, that means there should be shading there, right? So 0 is greater than or equal to 0 minus 2. So if I simplify that, I get 0 is greater than or equal to -2. Is that true? It's true. So again, highly recommend picking another test point on the other side. What do you want to pick? This point right here? Or here? Let's pick this point right there. What's that test point? 1, 2, 3, 0. Okay, so I'm going to sub in 3 for my x and 0 for my y. So 0 is greater than or equal to 3 minus 2. So if I simplify that, I get 0 is greater than or equal to 1. Is that true? That is false. So I have now verified I am on the way to get a perfect score on this question, because I know I should be shading where the 0, 0 is and not where the 3, 0 is. So last step, shade all of that part on that side of the line. And that's all we have to do. Pretty easy. How would I graph this line? So in grade 10, you learned another method of graphing, and that was the x and y intercept graphing, where you figure out what the x-intercept is and the y-intercept, you plot it, the 2 points, and then you connect. So remember back in grade 10, it was 2x minus 3y equals 6. We're not going to worry about the inequality right now. How would I graph that line? Well, when the x and the y are on the same side together, you could move it over and solve for y, but that's too much work. How do I find the x-intercept? Set y to 0. What happens when I set y to 0? This whole thing goes away, and you're essentially left with 2x equals 6. And you can do mental math and figure out what it is. What is? 3. It's 3. Y-intercept. Again, set x equal to 0. What happens? This whole thing here goes away, and you're left with -3y equals 6. So what is the y-intercept? -2. So after we know the x and the y-intercept method, now I can just plot it. So x-intercept is 3. So 1, 2, 3, put a dot, right? And my y-intercept is -2. So right there. And then we take our ruler and we connect the dots. Now, am I going to connect it solid or dashed? Dashed. So I have actually a dashed line here. And right here. What's cheating? I'm going to. Oh, I got to. There, I'll try making it blue again. There we go. And I just got to put an arrow at this end. Okay, so does everybody have their line? Okay, so now the next step is getting a test point. So again, if it doesn't go through 0, 0, 0, 0 is the easiest test point to ever test. So we're going to test 0, 0. So we're going to sub 0 in for x and 0 in for y. And what's nice about 0? Wipes it away, right? So we get 0 is less than 6. Is that true? That is true. Just for fun, we're going to do a second point. Which point do you want to do on the other side of the line? 1, -2. Oh, that's so close, though. Just to be safe, just in case my ruler's up, let's go 1, -3. Just to be on the safe side, okay? You see what I'm saying? Because sometimes I might have shifted my ruler a little bit. Some of you are doing it by hand, and you might be really off. So 1, oh, we could even go 1, -4. But anyways, let's do 1, -3. We're going to sub that in. What's 2 times 1? What's -3 for this? And then I'm subbing in -3. -3 times -3. Plus 9. Is that less than 6? That's 11 is less than 6. So that's false. So we verified we are good to shade. Where are we going to shade? Where it's true, on the left side. So what do you think about that? So try example 3 by yourself this time. What do you think? Can you do it by yourself? Okay. So slope intercept, put a point on 1, up 1, over 1, yes? Then is this going to be a solid or dashed line? Solid. Okay. Oh, shoot, that's not solid. That's okay. The magic of technology, I can now select it and make it a solid line. At least theoretically, I should have. Let's try this again. Otherwise, I might have to erase it. There we go. Okay. So now we're going to do a test point. Again, first I'm going to put my arrows. Yes? So which test point did you guys use? 0, 0 works great. So I'm putting 0 in. 0 plus 1. So is 0 greater than or equal to 1? No. That would be false. So I'm going to test another point just to make sure. 1, -1. Yeah, -1, 1 is a better one because you need to have it on the other side of the line. So now I'm going to substitute 1 in greater than or equal to -1 plus 1. So 1 is greater than or equal to 0. Is that true? Yes. So now you verified it is, in fact, right there. Which makes sense because the y's are getting bigger on that side, right? Okay, so let's go on to example 4. We need to come up with the equation of this. So do you remember how to come up with the equation of the line? Yeah, if you can see the y-intercept and the slope, it's pretty easy to come up with that, right? That is y equals, I'm not going to put an equal sign because it's not, some up 1 over 2, so 1/2 x plus 2 is the y-intercept. So now we got to figure out, is this less than or equal to, greater than or equal to. So first off, it's a solid line. So we know we have the equal sign. So can anybody guess what it would be? When it's in this form, it's pretty easy to look at the y's and see what's happening where it's shading. It's getting less in number, right? So we're going to do that, but just to be on the safe side, we're going to do another test point. So what should we test? 0, 0. So let's sub it in. What do we get? 0 is less than or equal to. 0 goes in there, so that wipes that away. 2. So that's true, and I think we're good to go. If you want, you could do a second test point just to be on the safe side. Any questions about that? When we have a horizontal line, what does that equation look like? y equals something. So what does y equal in this case? Yeah, it's always 1. So we know it has an equal sign because it's solid. So now, is it greater than or less than? Greater than. Everybody knows which one's greater than and which one's less than? Less than looks like an L. Yes? Okay. Last example. So you can see the y-intercept, yes? And you need to have 2 points to get the slope. So here's another point so you can see how much it's going down to the right, so you know the slope is negative. Does everybody see that? So y is not equal to, and the slope is down 2 over 1, so it's going to be negative 2x minus 3. Did everybody get that as their equation? So now it's going down in number, the y's. Does everybody see the y level is going down? So that would indicate less than. So let's just do a test point just to make sure. Let's test 0, 0. What's supposed to happen when I substitute 0, 0 in? It better be false. So I'm substituting 0, 0 in, and I get 0 is less than negative 3, which in fact is false. So we did it right.